Hello everyone. In this video, I'm going to explain CAN cycles for turning and facing operations in CNC lathe. So first, these are some operations for which the CAN cycle is available in CNC lathe. So first is a rough turning cycle, that is stock removal in a turning operation. Rough facing cycle, that is a stock removal in facing operation. Finish turn and face cycle, rough boring cycle, finish boring cycle, and peck drilling cycle. So these are some cycles or some operations for which the CAM cycle is available in CNC lathe. But in this video, I am going to explain these first three operations, that is a rough turning operation, rough facing operation, and finish turn and face operations. So for these three operations, I am going to explain the CAN cycle. So first, we will move towards the first cycle or the first operation, that is rough turning cycle or the stock removal in turning operation. So this is the rough turning cycle. So while writing the rough turning cycle, so we have to write down two blocks for the rough turning cycle. So first block here, that is N50, and the second block is N60. So these are the two blocks which are used for the rough turning cycle. I have written these two blocks in a general form, but for understanding purpose, I have written the same two blocks in the example form. So first thing is what? The G71. G71 is the G code or the preparative function used for the rough turning cycle. So now we'll try to understand how to write down this rough turning cycle. So first block for this cycle is this one, that is in green color. N50, so obviously N is the sequence number. 50, this number I have chosen randomly. Next, G71, obviously G71 is the rough turning cycle. U 2.0, so now this U indicates depth of cut for each roughing pass. So in this pass or in this rough turning cycle, number of passes are there. So for each pass, depth of cut is defined by this word, that is U. So in this example, I have taken 2.0, U 2.0. So the meaning of this one is depth of cut for each pass. So these are the passes. So depth of cut for each pass is 2 mm. Next, R 1.0. So R indicate relief or escape of the tool. So relief means first here you can see the first pass. So this is the direction. So that is what the first cutting pass is taking place. So once this first cutting pass completes, this tool escape from the raw material. So in this figure you can see that this is the distance, that is E is the distance by which the tool is escape from the cutting material and it is moving back to its original position for the second pass. So the distance by which the cutting tool escape from the raw material is nothing but what? Relief or escape of the tool. So R indicates relief or escape of the tool. Here I have, in this example, I have taken 1.0. So 1 mm is the relief or escape of the tool from the raw material. So this is what? So this is the first block in the rough turning cycle. That is N50 G71. That is a rough turning cycle. U represents depth of cut for the each roughing pass. R represents relief or escape of the tool. Now next we'll go for the second block of rough turning cycle. N60, that is the sequence number. G71, that is the rough turning cycle. P70. So P70, the meaning of P70 is sequence number at which machining begins. So here these two blocks are there for the rough turning cycle, and the next block will be for the machining operations or for the machining purpose. So the next block will be what? N50, N60, the N70, from which the machining begins. So this 70 number represents the sequence number at which machining begins. And after some blocks, the machining operation will get ends. So this q represents here, sorry, I have used here p, so here q is there, q150. So q represents sequence number at which machining ends. So I have chosen this number randomly again, that is at this block number, at this sequence number, the machining is going to end. So again I will explain this P and Q in the example in detail at the end of this video. So next is U 0.3. So in this second block, the U indicates the stock live on x-axis for finishing operation. So here I have written zero point 0.3. So zero point 0.3 mm is the stock live along the x-axis for the finishing operation. Next, W. So W represents stock live on z-axis. So U represents stock live on x-axis. W represents stock live on z-axis for finishing operation. So here in this example, I have taken W 0.01. So here 0.01 mm stock is living for the finishing operation in z-axis. Next is F 0.2. So F 0.2, it represents feed rate, that is 0.2 mm per revolution. So in second blocks we have defined sequence number at which the machining begins. Sequence number, that is Q, represents sequence number at which machining ends. U represents stock to live on x-axis for finishing operation. W indicates stock to live on z-axis for finishing operation, and F represents the feed rate. So this is the rough turning cycle. Now next we will go for the rough finishing cycle. Rough facing cycle. So again, for a rough facing cycle, again we require two blocks. So again you can see here the two blocks which are required for the rough facing cycle in the general form. Again, for the understanding purpose, I have written the same these two blocks in the example form. G72. So G72 is the G code or the preparatory function for the rough facing cycle. Now we'll try to understand how to write down this cycle in these two blocks. So first block, again I have chosen, that is AN50, that is sequence number 50. G72, that is rough facing cycle. U2.0. So the meaning of U, or the U indicates depth of cut for each roughing pass. So in this example I have taken U2.0. So 2 mm is the depth of cut for each roughing pass. So in a facing cycle, so for the first pass, for the second pass, so whatever the passes are there in this complete cycle, for each pass the depth of cut is 2 mm. Next R, that is relief or escape of the tool. So R1.0. So again in a rough turning cycle I have explained. So what is the meaning of relief or escape of the tool? So the meaning is the same here in this case also. So R1.0. So 1 mm is the relief or escape of the tool after each pass. Now we'll again move towards the next block for the rough facing cycle. N60, G72, P70. So P70 is the sequence number at which machining begins. Q150. So Q is the sequence number, or it indicates the sequence number at which the machining ends. Again next U 0.3. So again the meaning is the same as a rough turning cycle. So 0.3 mm is the stock live on the x-axis for finishing operation. Again the W 0.01, again the same meaning like rough turning cycle. 0.01 mm stock is leaving on z-axis for finishing operation. Last F, that is feed rate, is 0.2 mm per revolution. The only change is what? The G72. So for a rough turning cycle, the G code or the preparatory function is G71, and for the rough facing cycle, the same G code, the G code used for the facing cycle is G72. So this is all about what the rough facing cycle. So now we will move towards the next cycle, that is finish face and turn cycle. So remember that for facing and the turning, for the finishing operation of facing and turning, the G code used is G70. For facing and turning, the same code is used, that is G70. So for finishing face and turn cycle, only one block is required that I have written here, that is N090. So again, this number is I have chosen randomly. So this is the sequence number N90. G70 is the G code for the finishing face and turning cycle. P70. P70 is what? Again, the P indicates the sequence number at which finish pass begins. Again, Q150, again it indicates the sequence number at which the finish pass ends. So only one block is required for this finish phase and the turn cycle. Now we will try to understand all these three cycles by using one part program. So next slide will be for the part program to understand the cycle, or how to use these cycles in the part program. So to understand these cycles, or how to use above cycles, whatever the cycles we have discussed, that is a rough turning cycle, rough facing cycle, and finish turn and facing cycle. How to use this cycle in the part program? So I have chosen one example to understand this cycle. So the example is, write a manual part program for machining the component as shown in figure. So here this is the component, final finished component. We want to machine this component, and this purple color shows the raw material, and we have to make a machining to get this final finished product. Use a roughing and finishing cycle for part programming. Assume yes, that is spindle speed 200 rpm and feed rate 0.5 mm per revolution. So we'll start for the part program for this roughing and finishing cycle. So first thing I want to mention here, for I have used the roughing cycle or the can cycle for the turning operation only for this case or for this example. So we'll go for this part program. So always for the FANUC controller, always the program begins with the percentage. So this is the sign which indicates the program begins. Colon 200, you can write any number here. So colon represents the program start. X0, this is the center line of the spindle. So this is the x-axis, this vertical axis is the x-axis, and the 0 of this x-axis is on the center line of the spindle. So this is the center line on the spindle, and this is the vertical axis. So 0 of the x-axis is at this point. Next, Z0, end of the part. So this is the Z axis, this horizontal axis is the Z axis, and the 0 of the Z axis is defined at the end of the part. So this is the X0 and Z0. So now we'll go for the first block of this program, N005, G28, U0, W0. So G28 represents a return to home position. So cutting tool return to the home position. Next, N010, G95 and G21. So here G95 represents the feed rate, that is feed per revolution. So that is feed is defined in mm per revolution. G21 represents, that is metric mode. So whatever the dimensions we have taken in this program are in metric mode. Now we'll go for the facing operation. So remember that I have not used the facing can cycle for this facing operation in this program. N0 M20, that is the sequence number, M42, T0101. So M42 represents the high speed range. Actually, three speed ranges are available, and three M codes are there: M40, M41, M42. M40 for the low speed range, M41 represents medium speed range, and M42 represents the high speed range. So I have chosen here M42, that is a high speed range. T0101, that is turret number 1 and tool offset value from the register 1. So next block will be N025 M03, that is a spindle on with a speed that is 200 rpm. M07, that is coolant on. Next, G00, that is a rapid movement or the rapid traverse to this position, X0. So this is the X0, and a Z5. So Z5 means what? From this point, 5 mm distance. So somewhere here, rapid movement of the cutting tool is taking place for this position, that is X0 and Z5. So next block is G01, that is the linear movement. G01 represents the linear movement. Z0 F0.5. For this linear movement in the cutting operation, the feed rate is 0.5 mm per revolution. So G01 Z0. So now the tool moves from this position to this position, and now the facing operation will start. Next block, X102. So now the tool moves from this position to this position. So this distance, this total distance or the diameter distance is 100 mm. So you can see the diameter distance is 100 mm. Remember that here I have used diametric programming mode. So in diametric programming mode, for every 1 mm programmed movement, the total actually movement of the tool is 1 mm. So for every, again I am repeating, this is the diametric programming mode. I have used this diametric programming mode, and in diametric programming mode, for every 1 mm programmed movement of the tool. So the programmed movement of the tool is 102, that is 102 mm is the programmed movement. So for every 1 mm programmed movement of the tool, actual movement of the tool is 0.5 mm radially. So for 1 mm program movement, tool actually moves by 0.5 mm. So here total movement is by distance 102, that is, this is the program movement, but actually tool moves by 0.5 into 102, that is for 51 mm distance. This is the diametric programming mode. So first, in the last block, the position of the cutting tool is this one, and now this next block represents, or this next block we have mentioned X102, that is the programmed movement, but the actual movement is by 51 mm distance. So now this tool moves from this position to this position, and it completes the facing operation. So this is the diametric programming mode. So now the tool moves to this position, that is at 51 mm from this point. Next is N045 G00, that is the rapid traverse to Z5. So Z5, so this is what, again it moves to Z5. So now the tool come to this position. So this is what, this is the complete facing operation. Now we'll go for the turning operation. So in this turning operation, I have used a rough turning, can cycle for this operation. So now next we'll go for the blocks which are used for this turning operation. So N50, G71, U2.0, R1.0, G71, P60, Q100, U2, W0, F0.5. So these two block represents the can cycle or the can cycle for a rough turning operation or rough turning cycle. So G71, so this is the G code for the rough turning cycle. So U represents, so that we have already discussed about U and R. U represents depth of cut for each pass. R represents the relief. So here the main thing is what in the second block, P and Q. So here N55, this is the sequence number for the second block of a roughing turn cycle. P60 represents the 60 number represents the sequence number at which the machining begins. So N060. So from this block the machining begins, and N100 at this block machining ends. So I have chosen here Q100. So this is the beginning of the machining and this is the sequence number at which machining ends. So again already we have discussed about this U, W and F. So in this case obviously U represents stock to loop for the finishing operation along the X direction. W represents stock to loop along Z direction for the finishing operation. So I have kept here 0 mm and the feed rate is 0.5. So now we have to define in next blocks, we have to define the complete machining operation or the machining operation for the final pass. So remember that each pass, so this is the first pass, second pass, third pass, and the final pass will be taking place at this position. So we have to define these this machining operation or the turning operation for the final pass in the next blocks. So the next block is N060. So G00, so that is the rapid traverse. X40. So X40 means what? This point. Remember that again I am mentioning I have used the diametric programming mode. So for each 1 mm movement of the tool along the X direction, only for the tool movement along the X direction, for 1 mm program movement along the X direction, actual movement of the tool will be 0.5 mm. So here we have written here X40. So X40 means what? Tool comes to here, and Z5. So Z5 means what? Now tool is here. Next, N065, G01, Z0. So G01 represents the linear movement and Z0. So Z0 means what? So now tool get the new position, that is what? Z0. So now tool is here now. So remember that X position already defined in the last block. So by default, it will consider the X position in the next block if we not mention the X position in that block. So in this block, we have not mentioned the X position. So by default, it will take the X position of the last block. So X position is, that is X40, and now Z0. So now the tool is here now. Next line, N070, Z minus 15. So already we have mentioned G01, that is the linear movement, that is for the cutting operation, and next is Z minus 15. So now the tool move from this point to this point. So this is the 15 distance, Z minus 15. So after this block, the tool reaches to this position. Now next block is N075, G02. So G02 is the clockwise interpolation. So this is the clockwise interpolation. So whenever there is a clockwise or anti-clockwise interpolation is there, so we have to use G02 and G03. So G02 for the clockwise interpolation and G03 for the anti-clockwise interpolation. So since this is the clockwise interpolation for radius 5, so G02 is used. X50. So when it reaches to this position after this clockwise interpolation, so the X coordinate will be what? 50. So this is the 40 and this 5 and this 5, that is 10. So it becomes 50. So x 50, z minus 20. So obviously this distance is 20. So this is the minus 20 and radius is 5. So now after this block, this tool reaches to this position now. Next block G01. Again the linear movement from this point to this point. I want to make the operation. So from this point to this end point. So G01 code need to use, which shows the linear movement. So G01 x80. So when it reaches to this position, now the diameter is what? 80 mm. So therefore x80. Next Z minus 50. So again this G01 is used. So last we have already mentioned this G01, that is the linear movement. So it will move linearly up to this point, that is Z minus 65. So Z minus 65 is this point. So after this block, this tool moves or tool reaches to this position. Again, there is a clockwise interpolation. So same thing we have to use here, or the same code we have to use here, G02 x90. So this position is what? X90. At this point, x90, z minus 70. So this 50 plus 20. So this is the 70 distance. So it reaches to this position, that is z minus 70 r5. So radius is 5. So now it reaches to this position. Next G01. Again, so linear movement is required. So we have used a G01 x100. So after linear movement, it will reaches to this position, and here the diameter is 100 mm. So this is x100. So after this block, it reaches to this position. Next N100 G00 x102 z5. So G00. So here at the end of this block, this complete operation, or this complete last pass cutting operation is taking place. Now G00 we are using means what? Rapidly we want to move the cutting tool to the new position. G00 x102. So 102 means what? This is the 100 and 102. So 2 mm above this raw material. And Z5. So Z5 means what? So Z5 is here plus 5. So 1 X is 102, X is 102 and Z is 5. So now rapidly this tool moves to now this position. So this is the complete operation is taking place by using this cycle. So this is the turning operation by using turning rough cycle. Now we'll move towards the finishing operation. So this is, so whatever we have seen already. So this is for the rough turning cycle. Now we'll go for this finishing operation. So again, for finishing operation, we need another tool, or the finishing operation we need to change the tool. So we'll go for this line M42. So M42 is the high speed range. T02, that is turret number 2, and the 02 is the tool offset value from the resistor number 2. So we have changed the tool, that is turret number 2, for the finishing operation. Next N110 G70. So obviously G70 is the finish cycle for the turning operation. P60 Q100. So it will follow the same machining operation from sequence number 60 to 100 for the finishing operation, that is from this position to this position. So this is the completion of the finishing operation for the turning operation. Next line is G28U0W0. So after completion of the finishing operation, we have used G28, which indicates cutting tool return to its home position, that is U0 and W0. Next line N120 M05, that is what? Spindle off. M09, that is coolant off. Next N125 125 M30, that is the end of this program. So this is the part of program by using the rough turning cycle and the finishing cycle. So this is all about the can cycles for rough turning cycle, finish turn cycle, and facing for the facing operation and the finishing operation for turning and facing cycle. Thank you.